First we are going to see the first way. First way is a is equal to limit x tends to minus 1 x square. X square is equal to, what is the value of this limit? What we do here, we just directly put minus 1 at the place of x. So what we will get, that is 1. So this is the first way. In the solving the limits problem, we are talking about the substitution methods. In substitution methods, we are going to understand here, if we saw this type of problem, how we can solve and what type of problems fall into that substitution methods. So like the function should be continuous. If we gonna use the substitution method for solving the limits problem, we need to first make sure like the function is continuous. For, continuous, there is no breaks in the graph. Like if we take another example, like there is a function is equal to sine x, and we know that the sine x, this is what the signum function. It has two values, like if the x upon mod x, if this is mod, yes, this is mod x. So if x is not equal to 0, then we will get x upon mod x, or we will get the 0 function's value, we will get the 0 if x is equal to 0. So first we are going to understand this problem, this sin x problem, can we solve with the help of the substitution method or not. Substitution method, we need the function should be continuous, but here let me draw the graph, then that is very easy to understand this is continuous or not. The sin x function's graph is like this, 1, and this is what the 0, this is 0, this is 1, and this is minus 1. So this is the graph for the sin x. So this function is not continuous at x is equal to 0. There is a breaks in that function. So what we can say here, the limit x tends to 0 plus, and the function is a sin x, the function is sin x is equal to limit x tends to 0 minus, and the function should be sin x. If the left hand limit and the right hand limit will be equal, so we can say that the function is continuous. And if it is not equal, so we know that there is a break in the graph for that function. We ensure that. And first we are going to understand here, if it is not equal, what we can say about this function, sine function fx is equal to sine x. What we can say about it, like the function's value fx is equal to sine x, which we have. This function sine x, this is what we can say here, this function is not continuous at x is equal to 0. There is a break in the graph. Okay, so what we can say here, the function, the limit which is x is equal to 0 sine of x does not exist. This limit is does not exist. This is what we can say, does not exist. And let me take the third example, that is what we can say, third type of substitution method, what we can understand here, like let me change the color. So yeah, let me take the black one. So if there is a limit, like this is the some instinct about the questions of the limits which we are going to solve further, but here what we try to understand, like where we can use the substitution method actually and where we are not able to use that. So we are just trying to understand like what type of problem, if we get what type of way we are going to choose to solve that problem. Okay, so limit x tends to infinite 1 upon x plus 2 is equal to what? If we directly x tends to infinity, if it means that if we put x tends to infinity at the place of x, so what it would be? It would be x plus 2. X is the infinity, so infinity plus 2, what is equal to? It is again infinity. And 1 upon infinity, we know that if we increase the denominator's value, if we increase the denominator's value, the function's value should be, the limit's value is going to be 0. So what we have seen here, like limit x tends to infinity, yes, and 1 upon x plus 2, if we are putting infinity here, then the whole value is going to be infinity. And what we can say, 1 upon infinity is equal to 0. because we are increasing the value of denominator, so that's why we are getting the 0. What we actually doing, we are increasing the denominator's value. So that's all what we can say here. That's all.